So, welcome to module 10.5. In this module 10.5, we will be talking about handling objects. Now, what are objects? Objects are basically instantiations of the class. So, I have a single class and I could have multiple objects, right. So, now let us see how do we handle such objects, right. Now, the moment we see I have class point, field int x comma y, static int point count. Now, I have a constructor for that class which is called point new int ax int ay. Let x is equal to x, y equal to ay, let point count equal to point count plus 1, return this and then go off, right. So, this is the Jack code, and we will see how this is going to get modeled onto this, right. Now, we are going to convert it to a VM level program. So, what are the things? So, there are several memory segments that we have already seen. There is a local segment where these local variables will be allocated, and that local segment is for every subroutine, right. So, when I change from one subroutine to another subroutine, the local segment will change. There is an argument again, that argument is for every subroutine. When I go from one subroutine to another subroutine, it will change. This is again for every object. So, when I am executing a subroutine of a particular object, every subroutine is associated with an object, and so this is for every subroutine we have this. That is actually used as a temporary for doing certain array computations. We will see some good use of that as we proceed on this. Then pointer is basically used to adjust the values of the this and that segment, right. So, pointer 0 will go and change what is inside this, pointer 1 will change the start address of that segment. So, that is, and then of course, we have constant which we can go from 0 to 2 power 16 minus 1. Static segment is common to all the modules. So, there is only one static segment starting at 16 and going up to 255. And temp segment, there are some 8 temp registers which we can use. So, this is all the things that we have seen here. So, these are all different memory segments, and these memory segments are mapped. So, finally, on the machine there will be one linear memory which will go from 0 to 2 power 16 minus 1, and these segments will be mapped onto different parts of this memory. And of course, the start of these segments will be stored in the stack, and the first few locations of the memory will have the start of the current local, current argument, current this, current that, etc. will be there on the host RAM. So, we have seen this memory map when we were discussing the VM and also the assembly. So, now this is the overall. So, from here to what you see on the leftmost side to the rightmost side, this is how the entire variables of an object need to be handled. So, we use all these segments to actually map on the variables of the objects that you instantiate. Now, let us see how these things are gone. See, on the stack always that we have seen, the local and argument variables are always on the stack. And why it is necessary? Because when I move from one local to another local, right, one argument, when I move from one subroutine to another subroutine, the local and argument of one subroutine should be now stored, and the next local and argument has to come. So, we have seen this when we are doing the VM, and so the local and argument segments are always on the stack, and the current local and argument entries are there in location 1 and 2 of the RAM. This we have seen in the earlier past itself, right. So this is automatically taken care by your VM. So, when I do a call, there is a calling function. The calling function has its local and argument segments, and there is a called function which will have the local for. So, the call at the VM, the call VM actually takes care of. So, if you just say call, the implementation of call at the VM level will take care of setting up the local and argument segment of the called function. And when the called function completes and comes back, right, its response, the return will take care that the local and argument segment of the calling function is taken care of. So, function A calls B, function A has its local and argument on the stack. When it calls B, that call it will of the VM, right. So, there is a VM instruction called call. If you just invoke that call, the way we have implemented call will take care of taking this entire thing, and the way the call is implemented in the VM will take care of setting up the local and argument segments for the called subroutine, that is B. So, when B starts executing, its local and argument will be there, okay. And the way so when B returns, there is a return statement in VM, and the return statement will take care of reviving back the local and argument segment of the calling function. So, the movement of the local and argument segment from the called function to the calling function and calling function to the called function, the adjustment of this local and argument segments is automatically taken care by the way we have implemented call and return in the underlying virtual machine, right. That we have taken care. So, if you go back to module 7, 6, 7, 8, there we had actually done this type of an implementation, and I hope you remember those. If you do not, please go and revise that particular part, okay. Right. And as I mentioned earlier, the field variables are going to be part of the this. So, every time the location 3 in the RAM holds the pointer to the current object which is being handled. If I am executing a subroutine of some object k, right, the object the start address of where that object is stored is there in this, okay. Now, what will happen is that this actually stores the base address of that object. So, that is how the field variables will be mapped on to this 0, this 1, this 2, etc. So, in the case of point, x is this comma 0 and y is stored in the this segment with 1. So, we use the this to basically handle the field variables, right. Right, that is what we are saying here. When we want to operate on a particular object, we set this to its base address. From this point onward, high level code that uses field I of the current object can be translated into VM code that operates on this side. So, if I want to access field variable 1, I have to access this one here. So, we have already seen that, and this is how the field variables are handled. So, the other thing is that if I want to access RAM, right, if I want to access keyboard or whatever, that we have already seen, push 8000 pop pointer 0. So, now that this will now have 8000, and now I say push 17, yes, then pop this comma 1. So, in 8001 17 will go. So, look at this code, push 8000, right, pop pointer 0. So, 8000 goes and sits in this. Now, if I say push 17, 17 gets pushed on to the stack, right. Then I say pop this 1. So, this is 8000, 8000 plus 1, right, this is the index in that segment. So, 8001, 17 will go and reside. So, this is how I can access any memory routine I want. Okay. So, now when we are looking at handling objects, there is something like constructing an object and also manipulating the object. Let us see both of this in great detail, right. Now, I have var point p1, right. So, and let p1 equal to point dot new 2 comma 3. So, point is some class, in some class I am so okay, point is a class. In some other class, I am instantiating a variable of type point p1, and I am saying let p1 equal to point dot new. Now, what is point? Point is a class. Inside that, there is a constructor function called point new. So, what is happening is there is a caller function which is calling this callee function here, right. So how is this object now constructed? So this is how it is constructed. First and foremost, we know that this is a constructor function. The moment this is a constructor function, so let us say this is a stack. When this function starts executing, this will be in the local variables because this is var. So P1, P2 and all are in var. D is also in the var. Since P1, P2, P2 is yet to be constructed, so it is 0. This is also in 0. Now what we say is that we say P1 equal to point.new 2, 3, right. Now somewhere in the heap, so there is a stack, there is some heap. Heap is the extra memory that is available for allocation for new objects, etc. So the operating system will now identify that your P1 point P1 is stored at 6012 and 6013, right. So now P1, if I say what is P1, if I, in C, if I say array, suppose I say int I of 10, what is I? I is the starting address of that array. Similarly, in this, what is P1? P1 is the starting address of where that point is stored. So what will be stored in the stack for P1? It will be stored 6012. Now in 6012, when I go and see, I will find 2, and 6013 I will see 3. So essentially this means your constructor function, what it is supposed to do, it needs to take some memory from your heap, allocate 2 entries in that heap, and pass on the address of the first entry, and that will be stored in P1. So whenever I want P1.x, I go to P1, I get the first address, then .x, I know that that will be field variable 1, so I will go to P1, and then .x will be field variable 0, so P1 plus 0, 6012, I will get 2 there, and similarly for y, I will get 3 here. So essentially what we need to do here is, the moment I say point.new 2, 3, now 2 locations are allocated in the heap on which I go and store 2 and 3. In addition, the first 2 locations, 2 consecutive locations are allocated in the heap in which we go and do 2 and 3, and the address of the first location is stored back in P1. So this is what we mean by constructing an object. So what essentially happens here, right. So what it means, so when I say let P1 equal to point.new of 2, 3, this is the VM code that you will be getting here. First I will push 2, I will push 3, then I will say call point.new of 2, right. So call point.new of 2, essentially that means there are 2 arguments that are need to be pushed here, right. Now so the contract is, the caller assumes that the constructor's code arranges a memory block to store the new object and returns its base address to the caller, right. So call point.new will return a base address to the pointer. So so what will happen, call point.new 2, and after this call finishes, what will be available? The base address of the pointer will be available, of the point will be available, that is whatever you say, and that I say pop back to P1. So P1 will store the base address where the 2 points are stored, right. That is what we need here, and similarly there is a code here. So this is basically what we need to get here. Okay, now let us see right. So let us now see how this resulting impact will happen. So we will say where point P1, P2 and D. So P1, P2 will be stored as local variables and D also as a local variable, and initially everything would be 0. When we say point.new 2, 3, when we call this function point.new 2, 3, the compiler will the operating system will allocate 6012 for it, and in 6012 and 6013 it will store 2 and 3, and it will return back the value 6012 here, right. And so this P1 will get the value 6012. Then we do point.new 5,7, again point.new will go, it will go and ask the operating system for 2 spaces. The operating system will give 9543 and 9544 for example. So it will go and store 5 and 7, and it will return back 9543 to this. So in terms of implementation, what happens is point.new will return 9543, which will essentially get stored into P2 here. So this is how 2 objects are basically created. So what we have seen now is what is happening at the caller routine. So call nothing, I just push the parameters, I call this function, and whatever result I just pop it onto this P1, right. That is what we are doing. But now we need to do what is going to happen at the callee routine. So what is the callee supposed to do? It needs, this is a constructor, so it should create a new object, and just like any method, the constructor must be able to manipulate the fields of the current object, right. So I create an object and I pick one as 2, another as 3, etc. Now the current object and it returns back that object, right. So it will return back, any constructor will return back a pointer to the object that it has created, right. Then what do you mean by creating an object? Creating space for storing those variables there, right. So this is the thing, and so it uses the this as a base address, and it will return back. So let us see how this is going to happen, right. So this is what is happening. So now when point got compiled, what had happened, your x and y are field variables, and without loss of generality your point count is stored at 0 location in static. It can be in some other location also. Now what will, now when I say point.new, 2, 3, this will start executing. So your VM code is something like this, right. Now we will say so first and foremost, since it is a constructor, there are 2 arguments to this. So we just first say push 2. So this is point.new, right. This is function point.new, and what we need to do is we will push 2. In general, what will the compiler figures out that how many local variables are there in the stack, and it will push that many amount of that value here. So if I have 10 variables, I will say push 10. Then I call a function called call memory.alloc with 1 argument, and what is that argument? 2. So this is like memory.alloc 2. This 1 stands for how many arguments. Suppose I have 10 arguments, 10 local 10 field variables here. Then I will say push 10, and I will say call memory.alloc 1. That means it will allocate 10 locations for those 10 field variables, and then I say pop pointer 0. What is pop pointer 0? Pop pointer 0 is that this will become the this address now, right. Now what we do, now I say let x is equal to ax. So x is equal to ax means push argument 0. So ax is the 0th argument. So push argument 0 onto the stack and pop this 0, because x would be in the this segment. X is a field variable, x will be in the this segment and at location 0. So now your x will get the value of the a. Now push argument 1, argument 1 is ay, and push argument 1 and pop this one. This will be in this segment. The 1 will be, the first variable will be y. So in the this segment, 0th variable is x, first variable is y. So or variable number 1 is y, variable number 0 is x. So pop this 0, push argument 1, pop this 1. So argument 0 is ax, argument 1 is ay. So this push argument 0, pop this 0 will do x is equal to ax, push argument 1, pop this one, will do y equal to ay. Then after that we have to increment point count, right. So let point count equal to point count plus 1, right. That is what we want to do. So push static 0. What is static 0? Static 0 will have the current value of point count, right, and push 1, of course, push constant 1, add. So this is whatever is there on the top of the stack gets incremented by 1, popped static 0. So the incremented value is stored back into point count. So this is what. Then what we do, we push return this, right. So we just put push pointer 0 and then we return. So what will be on the top of the stack? The address of the newly created point will be there, and that is what goes into this. Okay. So this return will go back here, and there we say call point.new, this return will go, and that I say pop p1. So p1 will get the value of the newly created object. So this is how an object is created and taken back, and this is the mapping of that syntax onto the VM code. Now we have understood the creation of object creation from a caller and a callee perspective. Now let us go and so we know construction. Now let us now talk about manipulation. Now this is here some class, I say let d equal to p1 dot distance of p2, where p1 is some class, p1 is a class point, p1 is a point, d is an integer, let d equal to p1 dot distance with p2, p2 is another point. Now the distance routine is actually a method int distance point other. So other is some other point. So what we do is that we find the difference in x coordinate. So what is the distance between x comma y and x1 comma y1 and x2 comma y2? This is x2 minus x1 the whole square plus y2 minus yn the whole square, square root of that, right. So that is what we are doing. So other is another point, and I am finding the distance of the current point, that is p1, from that point p2. That is what this means, p1 dot distance of p2, right. So p1 is a point, p2 is another point, I am finding the distance between p1 and p2. So for that I will call the method inside p1, right, with the other as p2. So what, so dx is a local variable which will be x minus the current point minus the other points x, other dot get x, and dy equal to y minus other dot get y, and what we do is we return the square root of that is x, dx squared plus dy squared, as you see, and this is and then we do this. So now this is the caller and this is the callee, and what will the VM code look like is what we are going to see now, right. So in general we are calling object dot foo of x1, x2, x3, some object, and within that object there is a routine foo of x1, x2, and actually in the target code there is foo of object x1, x2. Okay. So this is how this is going to happen, right. Right. So when I call object dot foo of x1, x2, what we need to do is we push the object first, because we need and we push x1, we push x2, all these things, because we need to know which object is necessary. So we push object, we push x1, we push x2, etc. Right. For example, let d equal to p1 dot distance of p2, we push p1, right, and then we push p2 also, which is the argument. Then we say call distance, call point dot distance or whatever, and that will return a value. Again you pop it to d, right. Okay. So how do we go about doing this? So this is the caller and this is the callee. Now what is going to happen, right? Now right, let us look at the callee thing, right. So again this is point dot distance. So what I do is, first and foremost I push argument 0, because I may want to use the field variables inside, right. So if it's a method, I may want to use the field variables of this point, which I am using in this case, right. When we say when I call p1 dot distance, I am using x and y, right, which are field variables of that current object p1, right. p1 is of instance point, right, and so this is an object of type point, and I am using the field variables associated with p1. So I need the this, right. So what I am doing here, as I told you, I am pushing argument. So whenever I am calling this, that's what, whenever I am calling object dot foo, I first push object and then push x1, x2, etc., and then call foo. So in this case, I first push p1 and then I push p2, then I call this distance. Essentially that means distance with this thing. So essentially the argument 0 that you see and the argument 1 you see, right. Argument 0 is p1, argument 1 is p2, right. So that is what we see here. First I say push argument 0, because argument 0 would have come from there, and that will point to where p1 is, right, and then I pop pointer 0, right. That means now I am handling p1. When I say d equal to p1 dot distance of p2, the distance routine corresponds to p1, right. What is now we are trying to do is that d equal to p1 dot distance of p2. Now when this is calling, when this p1 dot distance of p2, the way it is compiled is, first we will push p1, then push p2, and then we will call distance. That is what we have seen here. Push p1, push p2, and we will call distance. So what will be argument 0 here? The argument 0 will be pointer to p1. Argument 0 will be 1 will be pointer to p2, right. So before this point dot distance is going to execute, what we will see is that on the stack we will see p1 as argument 0, pointer to p1 as argument 0, and pointer to p2 as argument 1, right. Now what happens is we call that distance routine. So we start executing this part of the code now. Now this is that part of the code. Now what we are going to see here is, first and foremost, this particular routine corresponds to which object p1, right. So when I am executing this routine and when I say x, this x corresponds to p1's x, right. So that means that whenever I am accessing any field variable inside this distance, it should correspond to p1. So that is why, please note here that the first step would be push argument 0. So what is argument 0? It is a pointer to p1, and that argument, so the pointer to p1 is now pushed on to the stack, and that is popped back to pointer 0. That means the current this, whatever you are seeing as this the current this will now point to p1. So if I am going to access any field variable, then it corresponds to p1's x and p1's y. So that is the first two statements. So whenever I am calling a method, we need to ensure that the calling routine, the caller pushes the, whenever I am calling a method corresponding to a particular variable, it pushes that variable, which will be the pointer to the start of those field variables, and then it also pushes, of course, the other arguments. The 0th argument will always be a pointer to that object for which we are going to, on which we are going to execute, whose method we are going to execute. Please note that method corresponds to every object. Every instantiation has its own associated method, right. So p1 dot distance and P2 dot distance are different in the sense that when I am doing P1 dot distance, this x corresponds to P1's x and y corresponds to P1's y, while P2 dot distance if I do, then this x will correspond to P2's x and y will correspond to P2y. So after doing that, all the other things are same. So what we need to understand is that when we do, these two statements are very, very important. If these two are done only, the corresponding field variables will get from the corresponding object, right? Otherwise we don't know from where it will get. So this is one thing, that after that it's all quite easy, like pop pointer 0, this will be argument 0. So now I will say push this 0, call argument 1, call point dot get x 1, right. So push this 0 means what? So we are getting get x, right, get x of other dot get x. Now I am pushing this 0, push this 0 means what? I am pushing x here. Push argument 1 is what? Argument 1 is other, right, P2 is argument 1. So push argument 1, then call point dot get x, right, 1. So this argument 1 is so point dot get x of P2. So let us again do this. Push this 0 will push x into the stack. Push argument 1 will actually push P2 into the stack, because argument 1 is P2, argument 0 is this thing. Then call point dot get x, right, will then, which will basically call point dot get x with P2. So that will return, this call will basically return the x value of P2, right, and then we do sub. So it will do x minus the P2's x, then pop local 0 because dx is this thing, so pop local 0. Similarly dy equal to y minus other dot get y, we will do the same thing. So then we will say push local 0, call math dot multiply 2. So it will do local 0 is dx, local 1 is dy. So this will do dx squared will be on the top of the stack, dy squared will be on the top of the stack. We will add both of them. So and then call dot, the addition will now, after this add, dx squared plus dy squared will be on the top of the stack. Now I will do square root, I will get this. Okay. So this is how this routine gets compiled. So the most important thing that we need to see is the first two statements, namely push argument 0 and pop pointer 0, right. And the return value goes back, and so call point dot distance, that return value goes back, and then that I pop it on to D. So D gets the distance between these 2 points, right. So but these are methods which have a return value, but there are methods which do not have a return value, which normally we do using do. So do statement works with methods which do not return anything, while let statements will work with methods which will return something. So what when in the case of do, again when I say P1 dot print, we push, so this will say push P1 and then say it will say call print 1, right. So it will push P1 and call print with 1 argument. So again push argument 0, pop pointer 0. So we are now setting up the context of P1 here, because we have to do P1 dot print. So I am setting up the context of P1 here, and then do whatever you want. Then always we assume that any calling the VM code assumes that any subroutine, when it will return some value, right. So it has the VM routine, the way we have implemented the relation between calling function and called function is that the called function always will return something. That is how we have implemented VM. So in the case of do, certainly this routine is not going to give anything. So we put push constant 0 and then return. So this is, it's a void function, it's not returning anything, still I will put push constant 0 and return, and that will come back here. So this is how if it is void, this is how we compile that function. And this goes back, the return goes back here. So after we do that return, since we are doing do, we just call point.print here, and then this pop temp 0. Right. This is pop temp 0 because this is we are not going to use anything. So this is returning something, I have to pop it out because the stack has some redundant value, I need to pop it out. So this is the way we compile void methods. Right. So this is how the object manipulation big. Let d equal to p1 dot distance p2. We call this is the caller function. We understood how the caller function works. We understood how the callee function works. Right. So this is about handling objects. Now in the next module we will see how we are going to handle arrays.